All right, guys, yesterday we talked about the law of sines, which is just a proportion between the angle measure and the side that's across from it. And we use that to calculate all the rest of the stuff of a triangle, all the missing sides and missing angles. Sometimes you don't get the information that you need and you can't use the law of sines. Sometimes you might be given 3 sides and it says solve the triangle. Sometimes you might be given 2 sides and an angle, but it's not an angle and a side that correspond. So you have to use something called the law of cosines. All right, the law of cosines is a derivative. It's not a derivative. The Pythagorean theorem is a derivative of the law of cosines. Like, just to show you where this comes from, right? I have a right triangle. You guys are all aware of a squared, b squared equals c squared, right? What angle is right there? That's the 90 degrees. So at a 90-degree angle on our coordinate plane, if I look at the ordered pair, at 90 degrees, your ordered pair is 0, 1. And if you guys remember from your quiz, cosine is x over r, correct? So the x value at 90 degrees, the x value at 90 degrees in this ordered pair is 0. So if I have 0 over anything, doesn't matter what it is, what's your answer going to be? 0. So look at this formula. If I plug a 0 in here and I tell you that the cosine value is 0, what happens to this right here?
0.
It becomes 0, right? And if this all becomes 0, what formula do you have left over? That's the Pythagorean theorem, right? So that's where the Pythagorean theorem comes from. The Pythagorean theorem is just an extremely specific law of cosines problem. That only works, c squared equals a squared plus b squared, if you have a 90-degree angle. Any other angle measurements, we have to use the law of cosines. You can't use the Pythagorean theorem. That's why. All right, does everybody see that? Everybody got that? So moving along, this is what I just told you, what I just explained to you guys. In words, this is what the law of cosines formula is. I just explained to you about the Pythagorean theorem being a very specific, special case of law of cosines. But if you're given a triangle, there's going to be 2 situations where you're going to be given a triangle and you have to use the law of cosines. It's either A, where they're going to give you all 3 sides and they're going to tell you to solve and find all 3 angles. Or the other scenario would be they give you 2 sides and an angle, but it's not a corresponding side and angle. They give me B and C, but they don't give me angle C and B. They give me angle A, but they don't give me side A. So this is when you'd have to use the law of cosines. Now, again, on your test, the problem will say using law of cosines or using law of sines. So it's like, here you go, this is what you use. But secondly, we will also give you the formulas. And now I know you guys are looking at this and you're like, oh, it's 3 different formulas. It's really not 3 different formulas. It's the same exact formula the whole time. It's just different sides. So what you need to really take away from this is whatever side you're looking for, the cosine of that angle should be at the end of your formula. If you switch up B and C, in the first one, if you switch up B and C, does it really matter?
No.
Why not?
It's the same thing.
Not because it's the same thing. What are you doing to B and C?
Multiplying them.
You're multiplying them and then you're also adding them, right? Mm-hmm. So if I add 7 plus 8 or 8 plus 7, it's the same thing. What you need to keep in mind is whatever side you are looking for, the angle that you're given should be on the outside, or vice versa. If they give you the angle, if they give you the side you're looking for an angle, they should be at the bookends of the formula, okay? What I have written here in green is extremely important because I'm going to show you a little bit of a shortcut through here. You could use the law of cosines to solve every one of these triangles, every single answer, but it would take a very long time. So the beauty of the law of cosines is if you find the biggest angle and the longest side first, you can then use the law of sines to find the second piece and then add and subtract to find the third. But you have to find the biggest angle or the longest side first. Does everyone understand that? All right, so first thing I'm going to do is I'm going to look at this. I'm going to say, okay, here is my triangle. If it wasn't drawn, I would draw it. And I would know that C is the biggest angle because it's across from what? The longest side. Very good. So do you guys agree that C is the longest side? So what angle should we solve for first? We should solve for C. So think about all the things we need to find. We need to identify the measure of angle C. What else? Measure of angle A and the measure of angle. Yep. I know all three sides. I need to find all three angles. So if I'm going to use the law of cosines, which formula would I use? They're all the same, but given the letters, which one do you want me to use? The bottom one, okay? So I'm going to set it up and I'm going to say 12 squared equals 5 squared plus 8 squared. Again, would it matter if I switched 5 and 8? No. So minus 2 times 5 times 8 times the cosine of, I don't know what. Correct? Not, I should put C. Yeah. All right, now everybody in here has calculators, but we have to know how to use them. You can't put that entire thing in your calculator because cosine of C is an unknown. We don't know what the answer is here. So we're going to have to simplify kind of in parts. What is 12 squared? 144 equals, what's 5 squared plus 8 squared? 25 and 64 is? 89, okay. Minus, what's 2 times 5 times 8? So 80 here times the cosine of C. Now, guys, don't make a silly mistake. Can you say 89 minus 80 cosine C? No. If it was just 89 minus 80, yes, you could, but you can't. That cosine of C is stuck to 80. So what do we need to do to both sides? I'm going to subtract 89. We need to get the cosine of C all by itself. So what's 144 minus 89? 55 equals negative 80 times the cosine of C. Again, how do I get cosine of C by itself? We're going to divide both sides by negative 80. Good. So I get the cosine of C equals, what's 55 divided by negative 80? I get negative 0.6875. Is that the value? Hold on one sec, Sarah. Is that the value of my angle? No, that's the cosine of the angle. So how would I figure out what the value, what's the measure of angle C? What do you think I would do in my calculator? To cosine or to the opposite, the inverse? So you'd hit second cosine, second answer, or you put that in. Instead of, don't use sine, guys, you won't get the right answer. This is the law of cosines. Round to the nearest degree, 1 whole degree. What do you guys got? All right, you guys should get it close to 133 degrees. You should be practicing this in your calculator, guys, because if you don't, you won't know how to do this.
Did you divide by negative 80
Yep.
cosine C?
No, just negative 80. So I get here that angle C is 133 degrees. Sarah, what were you going to ask?
Why wouldn't you just subtract 89 from 80
Yeah, that's
and
what I was
divide by like whatever you get?
Why can't you combine 89 and... Because this is like saying 89 minus 80x.
Oh, it's attached to it?
Uh-huh, because it's multiplied, right?
Oh, yeah.
So you can't combine those two because that says 80 times cosine C. So the only way to get that 80 to go away would be to divide. Yeah, sure. All right, so now what do you guys notice? What do we have left over here? We could use the law of cosines again. But what have you discovered? What have you created between angle C and side C? I have the angle and I have the side measurement. So what can I use? What law can I use if I have the side and its corresponding angle? I can use the law of sines. Once you find the law of cosines, once you find the biggest side or the longest side or biggest angle, you can then, your next step, you can just use the law of sines. So sine 133 over 12, and then what angle do you guys want to find? Okay, so sine of B over 8. How do I solve this from yesterday? Okay, cross multiply. So 12 times the sine of B equals 8 times the sine of 133. Divide both sides by 12, and I get the sine of B is 8. Sine 133 divided by 12. 0.4874 or 75. All right, so then I'm going to hit second answer. We're not doing cosines, we're doing sine now. And I get 29 degrees. So angle B is about 29 degrees. So up here I'm going to say, okay, well my angle B is about 29 degrees. How can I figure out what angle A is without really thinking too much? I can add those two angles together, 133 and 29. So 133 plus 29 equals 162. And then I subtract 180 minus 162, and how many degrees are left over? 18 degrees. And there you have solved your triangle. So once you find the biggest angle or the longest side, your next step, then you can use the law of cosines, and then you can add and subtract. Now, what you guys need to do, just to make sure you didn't make any mistakes, right? What would happen if you got your answers and you got that the measure of angle C was 47 degrees, measure of B was 121, and the measure of angle A was 12 degrees. Just based upon the side lengths that are given, what's the problem with these angle measures? No. What's wrong with that? What have we preached from the very, very beginning? The biggest side, the longest side should be across from the biggest angle, yes? Yes or no? So look at C. Side C is the longest side, so angle C should be what? The biggest. So with this hypothetical situation that I just brought up to you guys, you should get answers and then check to make sure. The biggest angle should be across from the longest side. So if the given information is what is given and you guys came out with those numbers, you should be like, wait a second, that doesn't make sense. Because B is not the biggest angle, but that's the biggest angle that measure that I got. That means you did not solve in the correct order. You did something wrong in your calculator. Something didn't work, but you guys should go back and check and see, all right, my biggest angle should be C because that's the longest side. Is that true? Yes. My smallest angle should be A because that's the smallest side. Is that true? Yes. So just give yourself a little opportunity to go back and check just to make sure. Yes. All right, let's do these two examples. Okay. There is no picture, so what should we do? We should draw one, okay? So let's just draw. Again, you can draw your triangle the exact same way every time, A, B, and C. It's obviously not drawn to scale because 120 is an obtuse angle, and that definitely is not obtuse the way I drew it, but no big deal. So I have angle A is 120. I have side B is 7, and side C is 8. So identify, guys, you're solving this triangle. What are the three pieces? They gave us 3 pieces of information. We need to find 3. What are we looking for? We're looking for side A. We're looking for angle B, and we're looking for angle C. All right, so I need side A, I need angle B, and I need angle C. Well, would it be helpful if we found A first? Yes, right? It would be very helpful if we found A first, because A, we already know that's the biggest angle, 120. But if we find A, then we can use the law of sines to finish the problem, correct? So let's find the measure of A. I have A squared equals, I'm not even going to look at the formula because I know it's the other two sides. 8 squared plus 7 squared minus 2 times 8 times 7 times the cosine of 120. That is the only thing I need to see as far as work is concerned. The rest of it you can do in your calculator. If you do it piece by piece, I want to show you something that you have to be very careful with. Work through this with me so you see. You can put that whole thing in your calculator and get your answer. Try it. 8 squared plus 7 squared minus 2 times 8 times 7 times the cosine of 120, and then hit enter. And what do you guys get? Yep, you should get A squared equals 169. Now, very rarely does it come out to like a nice, pretty whole number like that. But how do we find what A is? You take the square root. We're going to take the square root of both sides. So here I get A equals plus or minus 13. Why does negative 13 not play into this situation? Because you can't have a negative side length. So you don't have to worry about negatives. Your answer here is side A is 13. Now, side note, I want you guys to do this in your calculator with me because I want you to see something. If you go in pieces, if you say 8 squared plus 7 squared, right? That's the first piece you get. What is 8 squared plus 7 squared? 64 and 49. 113. Okay, so 113. Then in the formula, it's a minus sign, right? Okay, now in your calculator, hit 2 times 8 times 7 times the cosine of 120. And what do you guys get?
I just get 169.
Well, you get negative 56. The reason that I caution you guys about this is because some of you will see negative 56 in your calculator, but you're like, oh, there's already a negative sign there, so I don't have to put it. That doesn't say 113 minus 56. What does that actually say? That really says 113 what? Plus 56, which would give you 169. So just be careful. If you know how to use your calculator and you can plug this whole thing in right here, go ahead and do so. But if not, you got to be really, really careful with your signs. So we just figured out that side A is 13 units, whatever it is. So if A is 13, what can I now use to solve the rest of my problem? I can use the law of sines because I have the angle measure of A and its corresponding side. So I'm just going to set this up and say, okay, sine of 120 over 13 equals, what do you want to find? B, okay. So sine B over, how long is side B? 7. Now what do? We cross multiply. So 13 times the sine of B equals 7 times the sine of 120. Divide both sides by 13. And you get the sine of B equals, in your calculator, guys, 7 times sine 120 divided by 13. You get 0.46632, something like that. That's not the angle measure, though. I need the actual angle measure. So I get the angle B. I'm going to hit second sign, second answer. And I get 27.8, which is close to what number? It's close to 28 degrees. Okay, good. So angle B is 28 degrees. Now, you can go through the law of cosines again. You could do the law of sines again. But what would be the easiest thing to do to find angle C? Add the two together. 120 plus 28 gives me 148. And then I'm going to subtract 180 minus 148 and get how much? 32 degrees. And there you guys just solved your triangle. So now let's check. Let's just make sure. The biggest angle is A, correct? Is that across from the longest side? Yes, 13 is bigger than 7 and 8. The smallest angle is what? B. Is that across from the smallest side? Yeah. Yep, so you guys are good. Good job. All right, let's do this example. Again, I don't have a picture, so what should I do? I should draw one. What are they giving me in this problem? They're giving me all sides. So across from A is 6, across from B is 9, and across from C is 4. How should I start this problem? What should I look for first? What angle? The longest side is across from the largest angle. So I know that I'm going to have to find angle A, I'm going to have to find angle B, and I'm going to have to find angle C. I'm solving this triangle. But you should start off, guys, with solving to find the largest angle across from the longest side. So I'm going to look for B first. So I'm going to use that formula. It's 9 squared, because that's what's across from B. What do I do with the other two sides? I square them, and I add them, and then minus 2 times the two sides multiplied together times the cosine of the angle I'm looking for. Again, that will be given to you. And now we just mathematically have to work this out. Let's do this in our calculator. What is 9 squared? 81, good, equals, what's 4 squared plus 6 squared? 52, right? Minus, what's 2 times 4 times 6? So I have minus 48 times the cosine of B. Can I say 52 minus 48 is 4? No, because that says 48 times the cosine of b. That has to stay. So I'm going to get rid of my 52. I'm going to subtract 52 from both sides. So what's 81 minus 52? 29, good. So 29 equals negative 48 times the cosine of b. Now what do? Divide by negative 48, good. Divide by negative 48. And you guys get the cosine of b equals, what's 29 divided by negative 48? Whoa. Negative 0.6041666667. Is that my angle measure for b? Yes or no? So I hit second cosine in this situation because we're doing law of cosines. Second answer. And how big is my angle? About angle b. About 127 degrees. So we got that angle B, guys, was 127 degrees. So write that in your problem so you can see this is 127. Now, you can solve the triangle. You can do the rest using law of cosines, but since we now have a side length and its corresponding angle, I'm going to use the law of sines. So I'm going to say sine of 127 over 9 equals the sine of A over 6, because I'm going to find angle A. So when I do that, we're going to cross multiply. So I have 6 times the sine of 127 equals 9 times the sine of A. I'm going to divide both sides by 9. And I get that the sine of A equals, in your calculators, guys, 6 times the sine of 127 divided by 9. I got 0.5324236, right? That's not what I want. I want the answer to that. I want this angle measure. So second sine, second answer. And I get 32.16. So angle A is about 32 degrees. So angle A is about 32 degrees. How do we figure out the last angle? I'm going to add 32 plus 127 and get 159, and then say 180 minus 159, and I get how much? 21 degrees. Good. So let's check. Let's just see if what we found makes sense. What is the longest side of this triangle? B. Is that across from the biggest angle? Yes. What's the smallest side of the triangle? C. Is it across from the smallest angle? So then we're good. Good job. Thursday, Friday, Monday, Tuesday. We are just going to practice these problems and practice and practice and practice. Because if you don't get to some sort of fluency with them, like meaning you can go through them pretty quickly, you guys won't have time to finish everything that's on the test. So that's really important that we know how to do this and we can get through it pretty quickly. All right? Sound good? All right, let's look at the last thing I want to talk to you about. All right? We talked about area of triangles. In geometry, you guys talked about this formula. Base times height divided by 2, or 1/2 base times height. We use this when we have a right triangle, correct? So in your last quiz, we had oblique triangles, and you guys used the formula A times B times the sine of C divided by 2. And that was when we had a triangle, and we had a side, and we had a side, and then we had the angle in the middle, remember? It was 2 sides and the angle included. Well, this time we're going to solve for area, but they're going to only give us 3 sides. All right, you can find the area of a triangle, an oblique triangle, when they give you just the 3 sides. It's called using Heron's formula. You will be given Heron's formula. So it's on the next slide. All right, this is Heron's formula. Before you guys freak out, it's nothing bad. First of all, semi-perimeter. Semi means half. A triangle is just half of a square, correct? So all you do is find the perimeter. You take the 3 sides, you add it up, and you divide by 2. But I need everybody real quick, on a side note. Write this down, please. Now change this to a 6. exactly how it appears on my screen, I want you to plug in your calculator. 6 plus 10, do it exactly how you see it. 6 plus 10 plus 10, and then hit divided by 2. And what is your answer? 21, okay? Now, let's look at this and use our brains. What is 6 plus 10?
16.
16 plus 10
26.
divided by 2.
Oh.
13. Why did your calculator tell you it was 21?
Oh, because it divided.
Yep. If you don't put things in your calculator correctly, guys, your calculator's not going to give you the right answer. If you put it in exactly like this, what the calculator did was it divided 10 divided by 2, because if you're talking about order of operations, division comes before addition. So 10 divided by 2 is 5, right? And 5 plus 16 is 21. But that's not what we need to happen. What we need to happen is for the calculator to add everything in the numerator, which becomes 26, and then divide by 2. All right, this formula will be given to you. The side lengths will be given to you. You literally are just plugging in. But if you don't plug in correctly, you're not going to get the right answer. So if your S value is off, look how many times you see S in the formula. Do you think you're going to get the right answer? No. So what you have to do is first find your value of S. You add up all three sides, hit enter, divide by 2. And then all you're doing in each parenthesis is saying your S value minus side A, S value minus side B, S value minus side C. All right, the number is going to get big, but that's okay because you guys have calculators. If I was asking you to do this by hand, okay, I get it, it's hard. But let's do this example. All right, I have a word problem, but it doesn't matter, guys. A business wishes to buy a triangular lot. What shape is a triangular lot? A triangle. Did they give me the measurements of all three sides? Yes. So just name them. It doesn't matter. I'm going to say A is 315. B is 125. And C is 280. Does it matter what I put for what? No. But the first thing we need to find is our S value. So you're going to take all three of those numbers, 315 plus 125 plus 280, add them up, and divide by 2. So you can do it two ways. You can do it all in your calculator using parentheses, or you can find the numerator, which is 720, and then hit divided by 2 and get that your S value is 360. You're literally adding up the three sides, hit enter, divide by 2, or put the whole numerator in parentheses. Now the next part is just the setup. This is the part I need to see. The formula is you take the S value, which is your 360, and then you're going to take each side, right? You're going to take your semi-perimeter and you're going to subtract each side from it. So inside, I need to see you guys write 360 minus 315 times, I need to see 360 minus 280 times, I need to see 360 minus 125. From this point on, if you want to do the rest of it in your calculator, you're more than welcome to. If you want to simplify as we go along, you're more than welcome to. I like to do that just to make sure, especially if you have decimals, because you don't want to round too many times inside your problem, and then you get further and further away from the answer. So 360 minus 315 gives me 45, so I have 45 under here. 360 minus 280 gives me 80. Then I have 360 minus 125 gives me, you guys get 235? Okay. Now what do I do with all those numbers underneath that radical? I multiply them. So you're going to get a big number, guys. 360 times 45 times 80 times 235. Whoa. $304,560,000. That's okay. That is totally okay. Is that my answer, though? No. My area is the square root of that. So hit square root in your calculator. And I get about 17,451.64. So we'll say 452. And it's feet squared because we're talking about area. So that is everything that you guys need for your test, which is not until next Wednesday. I still have like 28 makeups. So makeup is tomorrow. I will give your guys quizzes back probably Friday. Any questions you have, we'll go over. But Thursday in class, Friday in class, over the weekend I have a bunch of stuff. Monday and Tuesday next week, we are practicing. So we are ready for our tests. Everybody with me? All right, thank you guys very much.